Okay, hey everyone. Today's lesson is about angle relationships. So for this lesson, it's going to be pretty important that you have a ruler with you. So if you don't already have a ruler, let's take some time to get one. And also what also might be really good is a highlighter. Highlighter is really good to have. So take a moment, get those resources, and off we go. Okay, the first thing we're going to talk about here is polygons. Polygons. It's just shapes. Shapes that are enclosed, by at least 3 or more lines. Okay? More importantly, we're going to investigate, and for this particular part here, the sum of the interior angles of a polygon. So here's what we're going to do. We're going to be drawing polygons with the indicated number of sides, right? So 3 sides, 4 sides, 5 sides, and whatnot. And then what we're going to do is we're going to pick one corner or one vertex and draw all the possible line segments from this vertex to the other vertices. Or basically, we're just going to pick a corner and draw other lines to every other corner. When we're done, our polygon should be divided into a number of triangles. Complete the last 2 columns in the chart, and over here, the number of triangles you see and the sum of the interior angles in degrees, of course. And we'll see what we notice. Okay, so in this first one here, I'm going to pull out my ruler, and I'm going to draw a 3-sided polygon, which you might already know is a triangle. So we're going to go ahead and draw a triangle. All right, a nice blue triangle. And the next question says here, well, how many triangles are there? Well, there's just one. And as we might already know, all angles, or all interior angles of a triangle add up to 180 degrees, right? I'm pretty sure you might recognize that from grade 8. So let's go ahead and draw the rest of these shapes. Maybe first we'll draw all the shapes, and then we can start counting the triangles. So we'll do the next one here, a 4-sided polygon. So maybe, I don't know, some sort of rectangle. Let's go ahead and draw, not the best here. So we'll draw a rectangle. I think if you use a ruler, it'd be really great. Okay, there's a rectangle. Let's go ahead and draw a 5-sided polygon. You might know that it's called a pentagon. So we'll go ahead and draw one of those. Something, they're a little tricky. It's something like this. Yeah. If you remember those shapes from elementary school, I believe this was the yellow one, if you know what I'm talking about. And lastly, the 6-sided, let me give myself some more space here. The 6-sided, which is a hexagon. Okay, this one always gives me some trouble. So let's go ahead. We got 1, 2, right? 3, 4, 5, and 6. Something like that. Yeah? Not too shabby. Okay, we have our shapes. The triangle's all done. We know the triangle really well. So again, we're going back to this step number 2, and we're going to pick one vertex or one corner, and we're going to draw all the possible line segments from this corner to the other corners. So let's go ahead and start with we could even start with a triangle. Let's start in the bottom left here. We'll pick the bottom left. So we're going to start here, and we draw a line to that corner. And then we'll draw a line to the other corner. Yeah? And notice how there's just one triangle there. I mean, we're not shocked by that. In fact, we already did know that from the very beginning. But let's go with the rectangle. Okay? We're going to start in the bottom left. Now we're going to draw a line to every corner. So we're going to that corner, and that corner. And we are going to start in the bottom left. So watch what this looks like. We draw a line straight up. We're going to draw a line to the other corner. And finally, the last corner. And if you notice, inside of our rectangle, you see not one, but 2 triangles. 2 triangles. And if one triangle has the sum of its interior angles to be 180, then 2 triangles, would just probably be 2 times 180, which you might know is 360. Or maybe you already knew that. Maybe you're thinking to yourself, hey, this is a rectangle, and rectangle has 4 90-degree angles. and four 90-degree angles adds up to 360, which is true. But it's really important we nail down this triangle stuff because watch what happens with the pentagon and the hexagon. So we're going to pick the bottom left. So I'm going to pick right here, this bottom left. I'm sure you can see the cursor. And we're going to draw lines to each other corner. So we're going to draw one to this corner, which seems kind of useless. We're going to draw one to that corner up there. Draw another one to this corner. And we'll draw one more line to the last corner. And here we are. How many triangles do we see inside of here? 1, 2, 3. Okay, so the five-sided shape gives us 3 triangles. And again, the same logic here. If one triangle is 180, then 3 triangles could be 3 times 180. Let me go to my calculator here. 3 times 180 is 540 degrees. Degrees. Don't forget your degrees here, Mr. Yakamishin. And the last one, I guess we're going to start, I don't know. We can start anywhere. Let's go bottom left. I mean, there's not really a bottom left on mine, but we'll just go here. So I'm going to start in this corner, and we're going to draw lines to every other corner in this shape, or rather, vertice. That's another fancy word for corner. Like that. All right. We've done it. Let's count the triangles we have here. We got 1, 2, 3, and 4 triangles. Okay, 4 triangles. Interesting. You might notice something here, right? You might. So let's go ahead and finish this up here. Sum of the interior angles, I guess it would be 4 triangles. Each triangle is 180. All right. And then we go to my calculator. 4 triangles times 180 degrees. That's 720. Whoa, what happened there? 720 degrees. Okay. What do you notice? What do you notice? Maybe take 10 seconds, talk to the people around you, just to talk about what you notice here. I noticed that one triangle is just one triangle, okay? There's not much to notice here, okay? In this second one, a 4-sided shape, right? The number of sides here. 4-sided shape has 2 triangles, okay? 5-sided shape has 3 triangles. A 6-sided shape has 4 triangles. Okay, well, what about, let's just do this for funsies here. A 7-sided shape, probably going to have 5 triangles. An 8-sided shape, probably going to have 6 triangles inside it, okay? And that is some sort of pattern. The pattern is this. If you don't already see it, I'm sure you do. Whatever number of sides a polygon has, you subtract 2 from it, and that'll give you the number of triangles it has. Yeah? Let's go look here. What pattern do you notice? Well, to calculate the sum of the interior angles of any polygon, we can use a formula. We're going to say that the sum of the interior angles is equal to the n, which is the number of sides, right? Let's maybe write that in. N is the number of sides. N is the number of sides. You got to take away 2 from n, right? And then you're going to multiply that result by 180. Because this n minus 2 piece right here, like the number of sides is n, but n minus 2 is the number of triangles, right? Let me just type that in. Number of triangles, and we'll get that in blue, so it's very obvious. Yeah? Perfect. N minus 2 is the number of triangles. We multiply that by 180, of course, and that'll give us the sum of the interior angles. So what about a 10-sided figure? 10-sided polygon. Do we want to draw it? Maybe not. Maybe not draw this one. We know that the number of sides is 10, right? 10 sides. And if that's the case, then we can go ahead and say, okay, well, 10 minus 2, in brackets, times 180 will give us the sum of the interior angles. Yeah? So really we're doing 8 triangles times 180. And we do that in our calculator really quickly here. And that is 1,440 degrees. We'll put that degree symbol there for sure. So if there's a polygon that existed had 10 sides. All of the angles inside of that polygon add up to 1,440 degrees. Okay, now what about something with 23 sides? 23 sides, yeah? That means the number of sides is 23. What we're going to do is take the number of sides, 23, subtract 2, times it by 180. Okay? If there's 23 sides, that must mean there are 21 triangles inside of that thing. 21 times 180 gives us 3,780 degrees for a total sum of the interior angles. Lastly, okay, now we're really using our imagination here. If there's a 106-sided polygon, I don't even know what you'd call that. That would just be, that'd be humongous. So we know the number of sides is 106. And I think you're getting the idea here, right? If there's 106 sides, that means there's going to be 104 triangles in there. Multiply that by 180, and we get a total sum of interior angles of 18,720 degrees. Okay, take a moment to write that down. Okay. Now, why are we doing all this? Why do we care about the number, or rather the sum of all of the angles, or interior angles, of any sort of polygon? Well, here's why. In example 2, they want us to solve for the value of each variable, okay? So here, if we look at this first shape here, how many sides does it have? 1, 2, 3, 4. It's got 4 sides. Now, we know that each and every one of these angles, so we got, I guess this is 90 degrees right there. You might already know that. We got this angle here. We got this 70 down here. And this angle up here. What we know about all of these angles is that they all add up to something. Now, what is that something? We can go back and look at our chart here. 4-sided polygon. Okay, it's going to add up to 360. Okay, so what's that telling us is this. We know that 90 plus 3x plus 70 plus x plus 20 is all going to equal 360 degrees. So we can go ahead and write that down. And we're going to create some sort of equation. And look what this looks like. We got 3x plus 70, all right, plus 70, plus x plus 20, right, plus x plus 20, and of course, plus that 90 that's there, right? You see that 90 degree there? Plus that 90. All 4 of these angles added together has to equal 360. It just has to. So what we're going to do now is we're going to use our collecting like terms abilities. Yeah, we got 3x and 1x. We know that's going to create 4x. And then we have 70 plus 20 plus 90. So we collect our like terms, all on the left-hand side here. And what do we get? We get something like 4x plus 180 equals 360. And this brings us back to solving two-step equations, doesn't it? Because what we're going to do now is we're going to take this 180 and we're going to bring it to the other side. And when we do that, it's no longer plus 180. It is now minus 180. We get 4x equals 360 minus 180. And we can tidy that up. We know that 360 minus 180 is just 180. And then from here, in order to get rid of this multiplying 4, we're going to divide each side here by 4. And on the left-hand side, the 4's cancel. And on the right-hand side, we're just left with 45 degrees. So x in this case is 45 degrees. Okay. Take a moment. You can write that down. Okay. The next one. What do we got here? Example B. How many sides are on this thing? We got 1, 2, 3, 4, 5 sides. 5-sided polygon. Okay, 5-sided. What you can do is you can use that formula from before. We're like, okay, we got 5 sides. Take away 2. We got 3 triangles. 3 triangles times 180. All of these angles have to add up to 540. For sure. Undoubtedly. So that's exactly what we're going to write. We're going to add up all these angles and set it equal to 540 degrees. So here we got 5x, right? 5x plus 139 plus 139 plus 9x plus 9x plus 71 plus the 71. And then we got plus 92 plus 92. All these angles added up together has to equal 540. Again, we're going to collect our like terms. So we got 5x plus 9x, which is 14x, and then 139 plus 71 plus 92 adds up to 302. Okay. Same idea here to solve this equation. We're gonna take this plus 302. We're gonna bring it to the other side here. It'll now become minus 302. So we have 14x equals 540 minus 302. We'll tidy up that right side because 540 minus 302 is just 238. And at this point, I think you know what to do. We're dividing each side here by 14. And then x just equals 17 degrees. Okay. Great. That's polygons. That's polygons. Talking about the sum of the interior angles. We can use that to solve some problems. It's good stuff. Let's move on to the next phase. We got angle properties here. Now you might have seen these before, and if you have, that's great. Just be sure to follow along here because it does ramp up kind of quickly. This angle down here, we know it is 90 degrees, and we know that because we got this little box there. It indicates 90 degrees. It's a perpendicular angle, as we learned a couple of units ago. Okay. Now, a straight line on the ground like this, or just a flat line like that line right there. Well, how many degrees is that? That's got to be 180 degrees. And you might already have known that. And if not, it's fine. You can take a protractor. You can measure it with a protractor. Off we go. All right. Example 1, calculate the missing angle of each. Now, some of you probably already have a great idea. For this one here, you might already see the flat line at the bottom. And you know that's 180, right? Then you're thinking, okay, from the ground to there is 74 degrees. So what's left has to just be 180 minus the 74, which is totally true. Now, I like to kind of show this mathematically. So what I mean by that is like, let's just say this is x. Like we don't know what that is. So we'll say we know that x plus the 74 has to equal 180, right? Right? Like this angle here plus the 74 has to equal 180 because as we know, 180 is the flat line. So we'll take that 74, bring it to the other side of the equation, and it'll turn negative because it's currently positive on the left side. And I think you already had this in mind maybe from the very beginning here. And we got 180 minus 74, which is 106 degrees. Yeah? I mean, do you have to show it this way? Maybe not. I think we're clever enough just to do 180 minus 74. Like that's totally fine. Even here, again, you see this 90 degree here, but you do know that this chunk right here is 65. So you're probably thinking, you're probably thinking the fast way, but if not, here's a great way to do it. We can do, well, whatever this angle is, we'll call it x again. X plus that 65 has to equal 90, right? And if that's the case again, we're going to bring this 65 over here. It'll become minus 65. And 90 minus 65 is just 25 degrees. So this little spot right there, it's got to be 25 degrees. Hey, and this one's got to be 106 degrees. Okay. And over here, well, this is kind of weird because it's outside of the triangle. Yeah? So I'm going to call this B. On the inside of this triangle, like if we're just focusing in on the triangle, you see this triangle here on the far right? We have 2 out of the 3 angles. We got 31 degrees, we got 70 degrees, and we got something. A, we call it. Now we do know that A plus 70 plus 31 has to equal 180 degrees, doesn't it? So we can do, well, A is going to equal 180 minus 70 minus 31. That just means A is going to be 79 degrees. So right in here, we can go ahead and just maybe chalk this up. We can go in here and say, okay, this is 79 degrees. All right. Now, if that's 79 degrees in there, yeah, and this, again, you might be able to see it. This is a flat line here. If that's 79, then whatever's left over here has to equal 180. Has to equal 180. So what we can do to solve for this b, this blue b over here, is we can say, well, b is going to equal 180 minus the 79, which means that that little spot right there has got to equal 101 degrees. This outside here is 101 degrees. Now, there is a math kind of principle for this. I don't really need to get into too much detail with it, but because this is an exterior angle and it's opposite two given interior angles, a really quick way to do it would just be doing 70 plus 31 is 101. And it is a kind of a quick math principle. Does it come in handy? Not really. I mean, the way we've done it intuitively is quite nice as well. But I want you to know that that does exist. It's not like it's going to come up on a trick question or anything like that, because there are ways around it, but it does exist. Okay. The next phase here, opposite angles and parallel sides. You probably have seen this stuff before. When two lines cross, two pairs of opposite angles are formed. So when two lines cross like an X, like this, we get two pairs of opposite angles. And opposite angles are equal to one another. So we can put equal there. They're equal. Okay, in this first little bit here, they say, what are the pairs of opposite angles in the following diagram? Okay, well, if we had a protractor, we could certainly measure it. But what the protractor would tell us is this angle B, whatever it is, angle D is going to be the exact same thing. It will. Same with this, angle A and angle C. They would be equal to one another. You can write that down. B is the same as D, and A is the same as C. And the reason why we know that is, one, well, we could have measured with a protractor, but another reason is because they are opposite. They're on the opposite sides, right? A is opposite to C, and B is opposite to D. So maybe we could try a little example here. It says find the value of angle X, angle Y, and angle Z. Okay, well, all they give us here is 70 degrees. Now, if this down here is 70 degrees, if we're looking back to this diagram, well, we know that D equals B. And if down here, I guess this could be our D, if this is 70, then up here must also be 70 degrees. Yeah? Now, you might be thinking we're doomed because that's as far as we can go. And it does look like that. It totally does. But don't forget, these are just straight lines. Check this out. Here, let me make this pretty obvious. This is a straight line here. And here's what we know about the straight line. I mean, okay, this diagram is certainly not to scale. That doesn't look like 70 degrees. But anyway, if this right here is 70, then the remaining portion must, complete the 180 degrees that the straight line is. So that must mean that X is going to be 110 degrees because of the straight line idea. And if X is 110 degrees and Z is opposite of X, then Z must also be 110 degrees. And that's how that kind of works. Now, these patterns, these parallel lines, you see these parallel lines? We know lines are parallel when they have this little indication here, this little arrow. See these little arrows? They're telling you that this line is parallel to that line, meaning that those two lines will never meet each other. They'll never meet. And when you have two parallel lines, and also this line that comes down, right? A line that kind of goes through the pair of parallel lines. This line does have a special name. This line is called the transversal. The transversal. I'll write that down. Transversal line crosses two parallel lines. Maybe you'll get that in purple. Yeah? The transversal line, it crosses two parallel lines. Now, when you have two parallel lines and a transversal, there are a ton of angle properties that arise. And you might even remember this from grade 8. And if you do, that's awesome. If not, here we go. We have first this, it's called the Z pattern. And if you look closely, you can see this Z. You see the Z? Now, in this Z pattern, the angles that are equal to one another would be the angles that exist in the armpits of the Z. So if that's A, then that's A. Those would be equal to one another. Now, the thing about the Z pattern is that it can go, normally like a Z. And it could also go, I'll do this in green, it could also go backwards as well, such that the other armpits of the Z, like this over here, B, would equal B. Those two angles would be equal to one another. So Z's can go forwards and backwards. In fact, moving on to the F pattern, F's can do the same idea. Now the F pattern is like this. You can see this F just like that, right? Similar to the Z, the armpits of the F, meaning in here, in the armpit of the F, those two angles are equal to one another. The thing about F's is that they can also go backwards, kind of like the Z pattern, right? You see the F going backwards? They can also be upside down, like this, yeah? Upside down F. And they could also be backwards and upside down, like that. So there's a whole bunch of different F patterns. There's 4 F patterns you can see with a parallel line and the transversal. Lastly, the C pattern. It doesn't come up a whole lot, if I'm being honest, but it does exist. Okay, it looks like a C, just like this. And the C pattern's kind of special because instead of showing angles that are equal to one another, it says something like this. If this angle up here is A, and this angle down here is B, the C pattern says that A plus B equals 180 degrees. That's what they say. Now, these patterns do have names. They certainly do. And we can write those names down. But I also like the word Z pattern, F pattern, and C pattern. But I want you to know that they do have names. The F pattern is called alternate angles. That's what we would call that. These are called alternate. Like when angle A equals angle A, that's alternate angles. F pattern is called corresponding angles. And C pattern is co-interior angles. Co-interior angles, like that. Yeah, those are the patterns. They're great. Now, they do exist, and if you remember it from grade 8, awesome. If not, we're going to practice some. So let's go ahead and start applying some of these newly learned ideas. Okay, determine all of the missing angles. Okay, so in this case, it looks like we have this X happening here. There's no parallel lines. In fact, we do have opposite angles. You see that? Like if this one right here is 115, then D must also be 115. And if this is 65, then C must also be 65. Yeah? So we could say that angle C equals 65 degrees and angle D equals 115 degrees. Now make sure you put the degree symbol here. I wasn't able to type out the degree symbol. It wasn't cooperating quite well. Okay, and that's that. That's kind of a nice one. Now let's look at here. Like this thing looks pretty empty, doesn't it? And if you notice, these are both 115 degrees. I think maybe because they're saying, hey, look, it's an F pattern, right? It's an F pattern. Of course, in the armpits of the F, these are both going to be 115. Now, how does that help us get other angles? Well, let's think back to our other angle properties that we know. Let's focus in on just the top here. We're just going to focus in here. If this angle right here is 115, then opposite of that must also be 115, right? Kind of like what we did in question A. that can also apply down here, right? If this is 115, then guess what? That's got to be 115. You see that? Sorry. Now, how are we going to get more angles? I don't know. Well, we do know. Let's take this line, for example. This is a straight line. It's a straight line. Agreed? Now, a straight line has these two angles have to add up to 180 degrees, right? So if this is 115, what's left over for this to add up to 180 degrees? It's got to be 65, of course. And check this out. If this angle is 65, then opposite of that 65 is this 65. There you have it. All right, let me just erase this really quickly here. Now, you might have already guessed it. The same kind of idea applies to this straight line down here. If this is 115, this has got to be 65 because of that straight line idea. And if this angle right here is 65, then opposite of that is 65. Okay. Wow. Just from 115 degrees, we got all of these angles. Okay, I feel like we've already done this one before, kind of. Yes, I think it is. Sorry about that. Y's got to be 70. Has to be 70, right? And again, we pick on that straight line idea. This is a straight line. If this is 70 degrees, which it kind of doesn't look like it, but just for the sake of fun, let's just pretend it's 70 degrees. And this over here, it's got to be the remainder to make up 180 degrees. And if that's the case, whoops, if this is 70, this has got to be 110. And if this is 70 down here, then this angle Z has to be 110 as well. Or maybe you're looking at it that these are opposite of each other, 110 and 110. Maybe you're looking at it like that, and that's totally fine too. Okay, the last one down here. The last one. All right, lots of stuff going on. Opposite angles might not help us a whole lot because all we got is 60 degrees and then a whole bunch of letters. So the first thing I see, I see a straight line like this, and maybe we can pick on one last time that straight line idea, where if this is 60, then this has got to be the remainder for it to add up to 180, right? So 180 minus 60 is 120 degrees. So A down here must be 120 degrees. Okay, that's true. This is good. Now, how are we going to get angles at the other end here? How can we possibly get these angles when there's nothing really given? Well, if you look closely, we have parallel lines. And when parallel lines exist, we have a whole bunch of angle properties that also come to exist. I'm not sure where your brain goes first, because maybe, there's so many different things to do in this situation. But if you look like this, you might notice some sort of F pattern. See the F? So if this is 120 in this armpit of the F, then there's another 120 under that armpit of the F. Yeah? And again, we're going to pull on that straight line idea. Here we go again. Look at this. It's really, really useful. If that's 120 down here, angle C, then angle E must be 60. Right? This has got to be 60 degrees. Not too shabby, is it? And if that's 60 degrees, then angle B must be 60 degrees. And if this is 120, then opposite has to be 120. And look at that. A whole bunch of angles that we got that look nearly impossible to get. Nearly impossible. All right. Enough playing around. There are a total. We got 1, 2, 3, 4, and then I tried to ramp them up on you. We got 5 and 6. There are a total of 6 questions that each subsequently get a little bit tougher as you go. Okay? And it's our job to determine the value of the variable, but also what they want us to do is give reasons for your answer. So maybe we can do the first one together. This right here, we got to find angle A. How can we find angle A? Well, if you look at this, we got this, see this Z happening here? See that Z just like that? This is telling us that this armpit of the Z is 117 degrees. Therefore, the other armpit of the Z has to be 117 degrees, right? So we know that. Now, what's the reason for that? Now, can we say Z pattern? Like, yes, we could. But what we really should say is the reason is alternate angles. Oh, my penmanship. I'm so sorry here. I'm trying my best. Alternate angles. So how about this? How about you try number 2, 3, 4, 5, and 6, and you can pause the video and do them now. Give them a shot. And if you choose to, great. If not, I'm going to start taking them up right now. Okay. Number 2, we got 87 and B. So, how can we do this? We got parallel lines, which is really nice. This is the armpit over here. So how about this backwards F like that? Right? This is 87. Therefore, angle B must also be 87 degrees. And what's the reason for that? Well, let me type it. It is corresponding angles. That's the reason. That's the reason right there. Okay, let's try this one. We got, now, there's a bunch of different ways to do this one. Maybe you solve for this 121, and then you did, 180 minus to get this angle over here, and then you Z pattern over there. There's 100 different ways to do it, truthfully. And whatever way you choose is probably not wrong if you're going to arrive at the same answer, of course. But I think the easiest way to see this one, is to look at the C pattern, right? Because this angle up here is 121. This angle down here is unknown. And what we know about the C pattern is that we know that this angle 121, let me go down here. We know that 121 plus C must equal 180 degrees, right? This is what we call the co-interior angles. So we're going to bring that 121 over. So we'll say this is minus 121. And angle C, let me pull out a calculator here. 180 minus 121 equals 59 degrees. That's got to be 50. Oh, where am I going? 59 degrees. So we'll say angle C is 59 degrees. And the reason is co-interior angles. Or maybe you're thinking C pattern. Yeah? Okay. This one got tough. Where do we start? Well, first I think we could start with X. X, because I think X is going to be 65 degrees. And the reason, whoa, that's a weird looking 5. 65 degrees. And the reason for that is opposite angles. Okay. Whoops. Say 65 degrees. Alrighty. Now, is there another way to get Y? Oh, I see this. Look at this. Parallel lines. We got this backwards F. Backwards F. You see that? So Y must also be 65 degrees. And the reason for that is corresponding angles. It doesn't even fit on my page here. And we can go ahead and type or input here 65. I like to draw all over these diagrams if you haven't noticed. It's the best way to do it. I feel like I just like it. I don't know why. And lastly, Z, well, this line right here is a straight line. And if this piece is 65, then the rest of that, must be 180 minus 65. And that'll be 115 degrees. And the reason for that, maybe we could say something like straight line is 180. So that's how we got that, right? I guess that's a good enough reason. Okay, on to the tougher stuff. This is tough stuff. Honest, this is tough stuff. I think, whew, here we go. Where can we start? I'm looking at number 5. Where can we start? The only angle, okay, I guess they give us 50 in here. Then they give us this 60. Can this 50 help us? Oh, maybe it can. I don't know. My brain goes right to the 60 degrees first. I don't know why. Because I see this. I see 60 and I see y, and right away I'm like, okay, those are opposite angles. So y has got to be 60 degrees, and the reason for that is opposite angles. That's where my brain jumped to right away. Maybe your brain was looking over here at this 50, right? If you notice, you got this. See that F pattern? Do you see it? Do you see it? Maybe I'll try to draw it more like an F, like this. See the F? So this is 50, therefore this is 50, right? Just tucked into the armpit, 50 degrees. And then we could say that would be the corresponding angles. And then angle Z, oh, how can we get angle Z? Okay, let me go ahead and just draw all over this thing here. Don't mind me. 60 degrees. All right. If you look at the top of this triangle, the top triangle, sorry, I'm just going to maybe highlight it to make it extremely obvious. See this triangle here? This is just a triangle. And it looks like we have 60 degrees in the bottom left. We have 50 degrees in the bottom right. And what we do know is that all angles in a triangle have to add up to 180. So we know that Z plus 60 plus 50 has to equal 180. So that means Z plus 110 must equal 180, right? You might have a better way to do this, which is totally fine. Z equals 180 minus 110, which means Z is, that's a Z, I promise. Z equals, sorry, does that say 110? Let me just fix that for us. Z's got to be 70 degrees. And the reason for that, I guess we could say sum of interior angles of a triangle has to be 180 degrees, of course. That's how we got that. All right, on to the last one, the very last one here. This one is tricky. I do like this one. I don't like it like I'm going to put it on a test, but I like it because it really makes you think and use some equation solving skills. You might notice that the Z pattern tells us something. The Z pattern tells us, that this angle of x plus 20 is equal to this angle of 3x minus 10. It tells us that they are, in fact, equal to one another. So check this out. We can say x plus 20 is equal to 3x minus 10, right? Let me bold that. Maybe let's do this one in blue, shall we? This is true. Now what we're going to do is we're going to solve this particular equation. I'm not sure how you want to do it. You can use whatever equation solving method you want, but I'm gonna bring this 3x over, right? So it'll become minus 3x. So we have here x minus 3x plus 20 equals minus 10, or negative 10. And then what I'm going to do, I'm going to take this plus 20 and bring it over here. So on the left side, we have x, well, let me get this bold, minus 3x equals negative 10 minus 20. Yeah? So we got 1x minus 3x, which is negative 2x. And that equals, well, negative 10 minus 20 is negative 30. And I want to double check that in my calculator. Negative 10 minus 20 equals negative 30. Okay. And then from here, we can divide each side here by the negative 2. Right? And they cancel, of course. And then we're left with x equals positive 15 degrees. Okay. Folks, that's the end here of angles. There's some great practice in the textbook. Please be sure that you're checking your answers as you go. Like, for example, if I assign number 1, 2, 3, when you finish number 1, I want you to go and check your answers in the back of the book. Like, check mark your answers in your homework so that you know. Because these questions do, very similar to this, questions 1 to 6, they get tougher as you go. So it's important that you stay on track with getting the correct answers before you move on to the tougher ones. Okay, well, if you need anything, please let me know. I'm always here to help. Have a great weekend, folks. We'll see you Monday.